Hi, this is Mr. Kwame. I can't be here today, so here is day 2's lesson. The first page is a warm-up. You should be able to do most of them without any problem. Number 4 might look a little weird, so just make sure both sides are fractions. Then you can cross multiply. You get 7 equals 1.25y, and you can divide by 1.25 to each side. Number 5, you could use Pythagorean's theorem on. If you don't remember that, it's a squared plus b squared is c squared, or a squared plus 3.5 squared equals 6.9 squared. So I rewrote it right here, and I squared both the 3.5 and the 6.9. Those are the numbers I got, 12.25 and 47.61. Then you subtract. And your last step is when you have a squared is to square root. So a is 5.95. Good. Next page. This page in the notes is just saying that that funny looking symbol is theta. And that's what we use when we're talking about an angle measurement. If it's an unknown, instead of x or y or z or any other variable, we typically use theta, indicating that what we're trying to find is an angle measurement, usually in degrees for us now, later in radians. So in this lesson, the main objective is to figure out what theta is equal to in terms of degrees. So we do that by setting up an equation just like before, using the trig ratios based on whatever sides we have. So when you look at theta, you notice that the side you have across from it, or opposite it, is 6. So we have the opposite. And then there's a side right next to it. And remember, adjacent means next to. But the side across from the 90-degree angle is hypotenuse. So we know that the 4 is adjacent because the hypotenuse is already taken. So that means we should be using tangent, because tangent of theta is always opposite over adjacent. So let's fill in what we know. Tan of theta is 6 over 4. Now this is where it gets a little bit interesting. Every time you've ever solved any equation in algebra, you've used something called inverse operations. For instance, if you had x plus 2 equals 3, very basic equation, in order to solve that, you used subtract 2, which is an inverse operation. X is 1. All right. So in the same way, the inverse operation of tangent, so tangent is what's with theta, and we want to get theta by itself. That's what all solving equations typically revolves around. We need to get rid of the tangent. In order to do that, we use something called inverse tangent. What it is we're going to make inverse tangent be a part of that side, and we're going to make inverse tangent be a part of the other side. It's got to do it to both sides, maintain equality. So inverse things, inverse numbers, inverse operations always eliminate each other. So when up here we had 2, but at -2, they eliminate each other. Same thing with these tangents. Those are gone now. We then have just theta is equal to tangent inverse of 6 over 4. Fortunately for us, that is on our calculator. You just have to find tangent inverse. It is just second tan on any calculator that has tangent. So second tan is tan inverse, 6 divided by 4 gives you 56.31 degrees. All right, if you did that and you followed it and you made this far in the video, give yourself a high five. It's not a clap, it's a high five. All right, let's try another one. This is really fun. We're all having fun now. So here's what you do. Notice what sides you have of your triangle. Remember, you're looking at it from where theta is. We want to see which sides we have. That one right there is opposite. That one right there is hypotenuse. So we have opposite and we have hypotenuse, and we want to find theta. The trig ratio that uses opposite and hypotenuse is sine. So we want to say sine of theta is equal to opposite over hypotenuse, or 5/11. If we did inverse sine to each side, so sine -1 would cancel these ones, and sine -1 over here, we get theta is equal to sine inverse of 5/11. So if you type that on your calculator, make sure you hit the second button. You want sine inverse of 5/11. And I got 27.04 degrees. It's good to put the degrees in right now because eventually it means something different if it's an angle measurement and it doesn't have the degree sign. It means radians. We'll talk about it later. These next few problems are, you're going to solve everything in the triangle. Like for instance, right now, you know this side length and you know this side length. You need to find this one. Those are just the sides, though. You also need to find the angles. We know 90-degree angle, but we have to find angle R and angle S. So we could do both right now. We need to solve all of it. I'm going to start with angle R. If you're at angle R, then when you look across, you see 3.8. That's the opposite. And 6.8 is the adjacent. So if I'm looking at R, we have the opposite and adjacent. That is tangent. Tangent of R is 3.8 over 6.8. We could use inverse tangent, which would mean R gives us tan inverse of 3.8 over 6.8. And R is then 29.20 degrees. Since we know that R is 29.2, we could figure out S because all the interior angles of a triangle have to add up to 180, as you'll remember from geometry. That would mean that angle S is 60 degrees, 60.8 degrees. Alternatively, we could have just done tangent of S, and it would look like this. Tans is 6.8 over 3.8, and then you'd inverse tangent each side. You'd get S is equal to tan inverse 6.8 over 3.8. Sorry, this is really sloppy. And so S is 60.8. Next, we need to find X, or side RS. That would mean it's the last side and we have everything. You could use Pythagorean's theorem. I'm going to use trig because it's funner. I just made up a word. Never heard it before, I'm sure. So I'm going to say, let's just start at angle R for fun. You could use angle S. Doesn't matter. I want to find X. So I'm going to say, all right, at angle R, if X is the hypotenuse, and 3.8 across from it is opposite. I could use the adjacent too. It just depends which one you like best. So if I'm going to use opposite and hypotenuse, that is sine. So I'm going to say sine of R, but R is 29.2, equals 3.8 over X. Now, as before, we need to make a proportion and cross multiply. We end up with 3.8 equals sine 29.2 times X. So we divide both sides by sine 29.2. When you do that, you get 3 divided by sine of 29.2 is 7.79. And that is what side RS is. So we've solved the triangle. We have every measurement about it. These last two slides can be done the exact same way as the previous slide. You have to solve the whole triangle, meaning find this side that you're missing, and you need to find angles E and angle D. I'll set it up, but you could just, at this point, look at the notes in Schoology and see all the work for this problem. So I'll start it off. Let's find angle D. If we find angle D, we know that 5.5 is adjacent and 7 is hypotenuse. So we would say cosine of D is 5.5 over 7 because adjacent over hypotenuse. You do inverse cosine, so D would be cos inverse of 5.5 over 7. And you get 38.21 degrees. There, I started it. You can check the rest of the notes. Good luck.